Let's see an application of Rolle's theorem to justify the existence of a real zero for a cubic polynomial, but the cubic does not have 3 real zeros, only 1. So from our days in algebra, we know that this cubic polynomial here, x cubed plus 3x plus 1 is equal to 0, or rather just the x cubed plus 3x plus 1 part, is a cubic polynomial. There might be 3 real zeros here. So it might cross once, cross again, and then cross a third time for 3 real zeros. Or it just goes across the x-axis once and only has 1 real zero. We're going to show that it only has 1 real zero. So let's consider the left-hand side of this equation, and we'll call it a function f. And if we evaluate f at -1, we have -1, -3, plus 1 for -3. So over here at -1, we're down here at -3. Our function value at 1 is 1 plus 3 plus 1, or 5. So at 1, we're up here at 5. Now, this right here is a cubic polynomial. It's continuous everywhere, so it's definitely continuous on this interval between -1 and 1. Therefore, we are going to have at least 1 0. The intermediate value theorem says that I either cross my x-axis or I have a discontinuity. And this function never has a discontinuity. Therefore, we have to have at least 1 0 by the intermediate value theorem. Now, we are going to employ Rolle's theorem to show ourselves that there can't be another 0. So let's summarize everything that we've done so far. By the intermediate value theorem, there exists a c value inside this interval, but there's some c inside that interval, such that your function value at c returns a 0, right? There has to be a 0 by the intermediate value theorem. Now, Rolle's theorem says that if there existed another one, so if it was the case that we crossed and then we touched it again, because my function values are equal to 0 there, Rolle's theorem says that I have to have a horizontal tangent line between them. So if there was another value, we'll call it C1, such that our function at C1 returned a 0. It's kind of like a proof by contradiction. We're going to show that this can't be true. So if there was another 0, then by Rolle's theorem, there has to be a point in between those two c values such that your derivative at the point is 0, right? There has to be a horizontal tangent line. Okay, but let's take our function x cubed plus 3x plus 1 and find its derivative as 3x squared plus 3. Now, you'll notice that this derivative is always going to be greater than or equal to 3. It's impossible for it to be 0. So we just reached a contradiction. If I had another 0, Rolle's theorem would tell me that there was a horizontal tangent line, or a 0 in my derivative. But this derivative right here can never be 0. In fact, it's always going to be positive, which means that this cubic function connects -1, -3, and 1, 5 by monotonically increasing, right? It never turns around and decreases. It never gives you yourself another 0 because this derivative is always positive. So you're always increasing. Therefore, you only have 1 real 0 for this cubic.